This is the Panduit Fault Managed Power System, or FMPS, the first certified Class 4 system in the market, brought to you by Panduit. Panduit FMPS is a power delivery system that transports power in a pulse current waveform, which allows it to deliver significant power over long distance safely and efficiently. Panduit FMPS has built-in fault detection redundancy. If a fault occurs, the system will detect it and stop power transmission within milliseconds. Its safe power distribution allows technicians to install it with no conduit, junction boxes, breaker panels, or permits, making it faster to deploy while saving up to 40% on material and installation cost. Compared to traditional DC power distribution, such as Class 2, Panduit FMPS can deliver up to 6 times the power over 30 times the distance while using less copper cable. The Panduit Fault Managed Power System consists of 4 components: transmitter chassis, power supply unit, transmitter module, and receiver. All system components comply with safety, EMC, and environmental regulations for reliability. The transmitter chassis is a rack-mountable 1RU chassis that usually resides at the head end of a building where a local power source is available. The chassis has hot swappable bays in the front and back. It can take up to 3 power supply modules in the back and up to 9 transmitter modules in the front. A power supply unit takes standard AC power and converts it to DC. Power supply units slide into the back of the transmitter chassis. Once inserted into the chassis, they can be plugged into a wall outlet or a rack PDU using the provided cable for ease of installation. A transmitter module converts DC power, supplied by the power supply unit, into pulse current or PC. Transmitter modules slide into the front of the transmitter chassis and deliver PC power to a receiver using 14 to 18 gauge twisted copper conductors. A receiver takes PC power from a transmitter module and converts it to DC. Receivers are wall-mountable, distributed around the building near powered devices. A receiver can deliver up to 1,600 watts to power multiple end devices. Each transmitter chassis comes with a pre-installed network management card that connects the FMPS to your local network. Through a web-based or SNMP interface, users can monitor, troubleshoot, and control the system remotely for improved operational efficiency. The Panduit Fault Managed Power System is designed with flexibility and simplicity in mind. Its plug-and-play installation and configuration creates a scalable power delivery system to grow with your power demands. Panduit FMPS is a safe and reliable remote power delivery system that will go the distance. Welcome to the new world of power distribution with the Panduit Fault Managed Power System. For more information about Panduit FMPS, visit panduit.com/FMPS.
Hello, and welcome to Panduit's Product Preview Day, featuring the first Class 4 power system in the market, our Fault Managed Power Solution. Today, we will have a live demonstration from Senior Business Development Manager Mahmoud Ibrahim, followed by a Q&A session. We encourage you to submit your questions, and we will answer as many of those questions as possible in our time allotted today. If we are unable to get to your question, we will follow up with you after the webinar has concluded. Now let's learn a little bit more about Panduit's Fault Managed Power System.
I'm Mahmoud Ibrahim, Senior Business Development Manager at Panduit, in charge of bringing Panduit's recent innovation in safe and sustainable power distribution to the market, Panduit's Fault Managed Power System, FMPS, the first Class 4 listed system in the market. Panduit's FMPS allows you to deliver significant power over long distances safely and efficiently. When I say significant power, we're talking up to 600 watts per copper pair. Long distance, we're talking up to 2 kilometers away, about 6,500 feet. Safely, because it complies with the most recent standards, the UL 1400-1, which allows it to be a Class 4 listed system. That allows it to be installed by a low voltage installer. Now you can simply run your copper in the same pathway as your fiber, saving on installation costs, not having to run it in conduit, making it fast and easy to deploy. Efficiently, because we're pushing high voltage across the cable, which allows us to go that long distance to push that more power more efficiently. We believe at Panduit that the applications for this technology are endless. Whether you're trying to power a PoE switch at the edge, to enable PoE devices, or you're trying to power a DAS radio at the edge for a wireless network, the Pen Fault Managed Power System could be your solution to powering these devices at the edge. Class 4 is a new classification of power under the National Electrical Code, or NFPA 70. It's covered under Article 726. And to really explain what Class 4 is, we have to step back and look at the existing classes of power. You have Class 1, 2, and 3. Class 1, we're all familiar with. That's basically what's running in our buildings today. It can go up to 600 volts. It's great because you can push a lot of power, but it does require an electrician and it does need to be running in conduit. Class 2, you may be familiar with, as the most common application of it is power over Ethernet. It's limited to 100 watts and 60 volts. It's great because it's considered a low voltage installation because these are power limited circuits. However, they're very limited in terms of the power and the distance that they can go. Class 3 is up to 100 watts and 150 volts. It's not very commonly used. Most applications for it are for home theater and sound systems. But now there's Class 4. Class 4 is pointing to a new standard by UL called UL 1400-1. This standard is a safety standard. It's concerned with 7 different types of faults that if you were to develop a Class 4 power distribution system, you must be able to detect any of these 7 faults and turn power off almost instantly to make sure it doesn't cause any shock or fire hazard. So there are 7 faults, and this is what we're always concerned with electricity, fire, and shock hazards. The ability to comply with UL 1400-1 and become Class 4 listed now gives you the benefit of being able to push a lot of power, go long distance using a Class 4 system, but you can also leverage it as a low voltage installation because it's safe. So now you can have a low voltage contractor pull the cable for the system and run your copper in the same pathways as your fiber, saving on installation and making it easier and quick to deploy. You're looking at the Pen Fault Managed Power System, FMPS, the first Class 4 listed system in the market. The Pen FMPS is made of 4 parts and a cable. The first part is a transmitter chassis, which is a 1RU unit. It comes with a network management card, which allows you to connect it to your local network, and through our user interface using an IP address or using protocols such as SNMP version 2, version 3, or REST APIs, you can monitor data or even control the system. You can monitor things like temperature, voltage, current, power, how much power is being consumed, and how much more capacity you have left. You can actually also control each part of the system. You can turn on or off the transmitter module, the power supply unit, or the receiver remotely. The transmitter chassis is a rack-mountable unit, typically going to be sitting somewhere in the head end or MDF of your building. It has 3 slots in the back for power supply units to plug in, and it has 9 slots in the front for transmitter modules to plug in. So if you wanted to add capacity to this unit, you simply take a power supply unit and you plug it in. Each one gives you a capacity of 1600 watts. You slide a second power supply unit in. That gives you a capacity of 3200 watts. If you add the third, now you get the full capacity, which is 4800 watts. In the front, I mentioned 9 channels. Each one of these transmitter module channels outputs 600 watts. And they all have access to the power being supplied by the power supply units. You simply slide in a transmitter module, and now you can have 600 watts out of the transmitter module, and it goes out through Class 4 cable to the receiver. Now let's talk about the receiver. The receiver comes with its own bracket, and it's a wall mount unit, or could also be mounted inside an enclosure or on a rack. It has 3 input channels on the bottom. Each input channel connects to a single transmitter module. Distance and the size of the gauge of the copper cable matters in terms of the capacity of the receiver. So let's say if you're using 16 gauge, running at 450 meters to this receiver, for every transmitter module connected to the receiver, you get 530 watts out of the receiver. If you connect all 3 channels, that aggregates to the full capacity, which is 1600 watts out of the receiver. That's at 48 volt DC. The last piece of the system is the Panduit Class 4 cable. It's a 16 gauge 3-pair cable, which basically connects from the transmitter module to the receiver. Now let's take a look at the different components of the Panduit fault managed power system, how it works, and what happens when a fault occurs. Again, if you picture with me the head end of your building, this rack has a transmitter chassis. In the back of this chassis, we have a single power supply unit. That power supply unit is basically can take anywhere from 120 volt or a single phase 208 volt. It takes that AC power and converts it to high voltage DC. In the front here, we have 4 transmitter modules and the network management card. The transmitter modules are taking that high voltage DC from the power supply unit and then pulsing it on and off. This is our way of doing class 4 and detecting for faults. So each one of these transmitter modules is constantly looking for the 7 faults that are in the UL 1400-1 standard. Once a fault occurs, it only occurs in that one channel. That channel turns off. If the fault clears, that channel recognizes that. It's self-healing, so it will just turn itself back on. So we have 4 transmitter modules that are represented also in this user interface. This is the user interface that's basically connected from our network management card. Now remember, you can access this through an IP address, or you can pull data out of this and control it through SNMP version 2, version 3, or you can use REST API protocols. So if we look at this user interface, it's showing us the status of the system. Right now, I have 1 power supply unit in the back. I have transmitter modules 1 and 2 connected to a receiver that's powering our DAS radio and lights. I have transmitter modules 8 and 9 connected to our second receiver, which is powering our PoE switch. We can, through this user interface, get a lot of monitoring data, such as temperature, voltage, current, how much power is being consumed, how much capacity we have left. So for example, I can go to the capacity screen here and I can see every component of our system, how much power is being used, and how much capacity I still have left. I can go to a power supply unit, a transmitter, or even the receiver to be able to tell how much voltage is coming in, how much voltage is coming out, how much current is being consumed, what the temperature is. A very interesting feature of the Panduit fault managed power system is not just the monitoring, but also the ability to control. So if you want to troubleshoot a device at the edge by simply power cycling it, you can do that remotely, whether by logging into the user interface or by using SNMP traps. So for example, if I'm going to go to the control and manage screen here and go to our receivers, and I'm going to turn off our receiver that's powering the DAS radios and lights for us. So I simply go here, disable it, and you can see the lights and the DAS radio go off instantly. I can come back and turn that on, and there you go. This can be done remotely to troubleshoot any issues in the field. The other big benefit of fault managed power is the centralized nature. Aside from the fact that it's class 4, it allows it to be a low voltage installation. You can run it in the same pathway as your fiber. It doesn't have to be running in conduit. These are all benefits from a day 1 installation perspective. But when you think about the centralized power architecture now, this allows you to centrally back up your system with a single UPS. So if you had a number of devices at the edge, like a number of PoE switches at the edge, and you want to back them up, before you may have to put a UPS next to each switch. Now you can have one central UPS connected to our transmitter chassis, and now every switch that's connected to that is backed up centrally. You also have now metering, monitoring, and control capabilities from one central location. Now let's take a look at how the system behaves when a fault occurs. Going back to this screen here, I'm going to focus more on transmitter modules 1 and 2, which are right here. And those are connected to a class 4 cable in the back, so 2 pairs of copper cable running out to our receiver. And in that path, we're introducing one fault for each of these transmitter modules. One of the transmitter modules connected to a fire hazard, we're showing you one of the 5 different faults that are in the standard. And the second transmitter module is connected to a shock hazard, which represents one of the 2 faults that are in the standard. And we're showing you through this screen here what the actual shape of the current that's coming out of these channels. Each one of these channels is basically outputting this high voltage DC that is being pulsed on and off. Again, these 2 channels are powering our receiver, which is powering the lights and the DAS radio for us. So now I'm going to introduce one of the faults by simply hitting one of these buttons, introduce the shock hazard. You can see instantly that channel turned off. You can also see that it went red and it blinked red here. It actually did it so quickly. It knows that that fault is not there anymore. It takes it a few seconds and it will just restart itself automatically. Now notice that the lights and the DAS radio are still on because we still had a second channel running. So we had enough capacity from that second channel to power the receiver, which powers the lights and the radio for us. You can already see that that channel came back online and it's already now sharing the load with that first transmitter module channel. Now what I'm going to do is actually introduce a fault to both of these channels to see how the system behaves. I'm going to introduce a fire hazard fault and a shock hazard fault. If I go quickly here, you can see the LEDs blinking red. You can see the transmitter modules went red. You can even see the receiver went red. That basically means it's a major fault, you lost power. The system again, or these channels are self-healing. They already know that the fault is not there anymore. So it takes them a few seconds and you should be able to start seeing the channels come back online in this screen. Now you can see transmitter module 1 and 2 channels are back online. It takes a few seconds to push that pulse current or class 4 power out to our receiver. Once the receiver receives that class 4 power, it takes a few seconds for the capacitor to charge up and then it turns back on automatically. And as you can see, the lights and the DAS radio are back online. This now kind of represents and concludes to you how the Panduit fault managed power system works, the different components, the benefits that you get, the low voltage installation while being able to push a lot more power over long distance safely by running it in the same pathway as your fiber. And you have the centralized benefits. You can centrally back up your power distribution with a single UPS. You have monitoring and control capabilities that allow you to troubleshoot your system remotely and be able to tell how much power you still have available if you wanted to add a second or a third device to that receiver at the edge. To learn more about Panduit's fault managed power system, visit us at panduit.com/FMPS or contact your local Panduit sales rep.
At this time, we will begin our Q&A session with Mahmoud Ibrahim. And again, if you have any additional questions that you would like to ask, please feel free to submit those in the questions section, and we will get to as many as we can today with our time allotted. And we do have questions rolling in, so we've got some very interested attendees here, Mahmoud. Let's get started with our first question. Are all fault managed power systems Class 4 compliant, Mahmoud?
Thanks for that question. No, they're not. And Class 4 is relatively new in the National Electrical Code. It just came out for the 2023 version. And you have to go through a new standard, certified to a new standard called UL 1400-1 to get to a Class 4 compliance, which is somewhat of a big deal because that 1400-1 standard is a safety standard. It wants to make sure that if you develop a fault managed power system, that it adheres to all the safety regulations, or the system can detect all of the faults that are within that standard, that it detects them and turns power off instantly. And 1400-1 is not just that portion of it. So it's an umbrella standard that has many other underneath. So you have to do shock testing, you have to do fire hazard testing, you also have to do functional safety, where they go through and actually look at your design to make sure that if it fails safe and it's properly designed. They also have EMI, EMC testing. There is adherence to the IT standard 62368, as well as manufacturing standards. So you actually have to prove that the product that you're developing and have been tested by UL, when it's actually being manufactured, it goes through an end-of-line test that rolls through all these tests and makes sure that it actually functions before it's packaged up and shipped to the customer. So there's a lot there, and to kind of re-answer that question, no, not all fault managed power systems are Class 4 compliant. They have to get the 1400-1 certification.
Great. Next question. What makes Panduit's fault managed system different than those in the market?
Well, just what we discussed, really. The fact that it's the biggest difference is that Panduit's system is the only Class 4 system in the market today, and basically the first to ever comply with it. And what that speaks to is it speaks to the safety of the Panduit product. It basically speaks to the 9 months of testing that we had to go through with UL, hundreds, if not thousands of tests. I mean, we've had to do 500 tests per cable that we want to list with. Just on average, I'd say we tested probably, we did about 1,500 tests overall. So that's our biggest difference today, being Class 4 listed. Now, if you look at the details of the product, you'll find a lot of other differentiations. For instance, a big part of our system in terms of the safety detection, it's all hardware-based safety detection. That's a really big differentiation. It's hard to do, and it allows us to be what's called SIL 3 rated. SIL is safety integrity level. That basically speaks to the reliability of the system and how many nines. Achieving SIL 3 is really difficult. So our Panduit system is still SIL 3 rated. The UL 1400-1 standard only asks for SIL 2 to comply. So we kind of supersede what the standard asks for. And then if you look at the actual physical product and how it performs, you'll see very robust hardware, connectivity. You know, Panduit is a cable management and connectivity company, so we care a lot about how the product is how reliable the connections are. It's also a hot swappable system, so customer can start today with a base Panduit FMP system and later on grow it by just simply adding more channels to it. That's a great differentiation. Really, I can get into a lot of details, but I'll just I'll pause at that.
Perfect. Thank you. How do you handle security breaches that can affect fault detection?
That's a great question, and I kind of touched on it already a little bit, but I'll elaborate more. So in the standard 1400-1, there's really two paths for a company to come up with a Class 4 listed system. They allow you to do software-based detection for the faults or hardware-based detection. So if you go the software route, then you need to adhere to cybersecurity standards, which are continuously changing, and so you need to be updating your firmware to make sure that your fault detection, if there is a security breach, it is not affected. Now, if you go the hardware route, which is what Panduit did, it's kind of the harder route to go, but it does save us from having to worry about any security breaches. So the Panduit system does not rely on software at all for the safety detection. If there is a security breach, there is no way that they can trip the detection of safety faults. So they can maybe turn the system off, but they're not going to be able to kind of disarm the safety detection feature. And so that goes back to the differentiation. So each of our channels, we call them transmitter modules. We have two independent hardware circuits that do our fault detection, and they are purely hardware. There's no software affecting that at all.
Perfect. Yes, and next question, what shapes the demand for this new class of power?
First, let's talk a little bit about what it gives you. So the class 4, what it's really essentially doing is it's allowing us to deliver high voltages safely. So it's telling you can develop these systems that can push up to 450 volts. Now you have a mechanism to, if you can detect faults and turn power off within the limits of the standard, then now you're making it safe, just like a class 2 circuit, which means it becomes like a low voltage installation or low voltage circuit at the end of the day. So the benefit that you're getting is the high voltage. It's allowing you to push a lot of power, go long distances using very thin copper conductors, but at the same time doing it safely, which now means you can make it a low voltage installation, which makes it fast and easy to install. Doesn't have to be running in conduit, so you're actually saving on material costs day one from the installation. So that's what the product gives you, or class 4 in general gives you. And now if we talk about what shapes the demand, so what we're seeing in the market today, really applications for this are endless. A DAS deployment, for instance, they're usually trying to deploy these radios in remote locations in a building, and they're trying to get power there. And so, this is a great means to run power because they're already sending fiber out to that radio. Now they have a means to just pull a copper cable next to it and then make it a class 4 circuit to get power to that destination. If you think of a smart building, if you ask them people what a smart building is, you'll probably get 10 different answers, but the common answer between them, or you can summarize it as, it's more technology, more devices at the edge, and those devices are always going to need some sort of connectivity for bandwidth, and they're going to need to be powered. And so what you'll see shaping the demand is all these edge devices going up in buildings, whether it's a switch, whether it's an ONT, whether it's a camera outside in the parking lot. Those are all more and more are getting deployed at the edge, and you need a way to run power to them. You're already running fiber. The best way to really run power to them is just pull that class 4 cable and use a class 4 system to provide that power. You can even think of cases like in carrier signals, small cells for 5G and even 6G. You're going to get more and more of these small cells popping up in different poles. You need power there. You don't necessarily have enough power at that pole, and so that's another means to get power there. Electric vehicle charging stations. You're trying to deploy these in condo buildings or outside corporate offices or enterprises, and this maybe not suitable today, but this is where the future is going. You will see EV charging stations powered by class 4.
And our last question for today, what is the environmental impact of this new technology?
I'm so glad you asked that question because I actually missed a point in the last one, but I can make it here now. The big umbrella here, or the big picture here, is sustainability. That's what class 4 gives you, or is going to help you drive towards. It's kind of answering shaping the demand, and also this kind of how it impacts the environment. By pushing high voltage, you're using less copper conductors. So you're being very efficient in your power distribution, less losses, and you're using less material, less copper cable. In a lot of these systems that are going to be class 4, while it's not dictated how you do it, most likely many of them will be DC based. And when you talk about having an all DC powered building to avoid the AC to DC conversions that happen, I feel like class 4 has been the missing piece. It could not deliver high voltage DC up to 450 volts in this case safely. So it wasn't really done frequently. But now that distribution part is taken care of. So if you think of a complete end-to-end DC building, it's really feasible now. You can have renewable energy, solar panels, wind panels, whatever it is, which already provide high voltage DC as their source, as their output. That can be directly connected to a class 4 transmitter that then pushes, high voltage DC safely, class 4, over the cable out to some receiver at the end, and that receiver takes that high voltage DC that's safe or class 4, and then can output high voltage DC into devices. There are many devices out there today, switches, servers that are coming out that are directly take DC. So now you've eliminated complete AC to DC conversion. You can do a complete DC to DC to the end. So very impactful in terms of energy efficiency and obviously affecting your carbon footprint. You're also, as I mentioned, saving on the material cost, on the copper. So less copper that will eventually go in a landmine somewhere. Less conduit or no conduit being used, so less material. The impacts are huge, really. I don't think I have the numbers on them, but I foresee probably people will be making studies on how Class 4 will be a great impact to the environment and overall.
Thanks so much, Mahmoud. That concludes our Q&A session for today. As mentioned previously, if we were not able to get to your question today, we will be able to follow up with you after the webinar has concluded. So please feel free to submit questions and we'll be able to follow up on those after today when we are wrapped up. So thank you, Mahmoud, for your time. Appreciate you answering these questions. And any final thoughts, Mahmoud?
Yeah, I mean, I'm really excited. Panduit has introduced the first Class 4 system in the market. The excitement out there is immense. Thank you for hosting me.
Thank you to everyone for joining today. To learn more about the first Class 4 power system in the market, Panduit's Fault Managed Power System. We appreciate you spending the time with us to learn more about this new solution. And if you'd like to learn more, we encourage you to visit Panduit's website at www.panduit.com/FMPS. Thank you and have a great day.